So in this example that's also in your textbook, it talks about the quality assurance department for Cola Inc. How they maintain records regarding the amount of cola in the jumbo bottle. The amount of cola varies by a small amount, right? These machines aren't perfect. They have records on it, and it does indicate that the amount of cola follows a normal distribution. So that's kind of my first big piece of information, is that the population does follow a normal distribution. We're told that the mean amount of cola in the population is 31.2, and the standard deviation is 0.4. So remember, we can always abbreviate it by putting our mean here and putting our, oh, that's not the mean of x bar, that's just the mean, and then putting our standard deviation here, right? Nothing new about that. Okay. At 8 a.m. today, the quality technician randomly selected 16 bottles from a filling line. When they found the mean of this sample, they found that it is, actually that's not the mean of means, that's just this. The mean of this sample was 38.38 ounces. So they took all the 16 bottles, they averaged how many fluid ounces were in each one, and they found that it was 31.38. And so we're asked, is this an unlikely result? And so the way that we're going to answer this is we're going to use this Z formula that we have over here, right? We're going to say, all right, Z is equal to my X bar, 31.38, minus my mu, 31.2, divided by 0.4, divided by square root of, this is my N, 16. Does it make sense where I'm getting those numbers and why I'm putting them where I'm putting them? Okay. So then we calculate the Z statistic here, and we find that the Z statistic is 1.80. And so again, we go up here, and we're going to label this stuff, and we're going to say, all right, the average, population average is 31.2. So this is our ounces over here. We're curious about this 31.38 cutoff. We know that this is a 0 on our z-axis, and we just figured out that this is 1.80 on our z-axis. So then we're going to go into our z-table, and we're going to number one, remember that when we're calculating these areas under the curve using the z-table, it always goes from the middle out, right? So when you get the value in the z-table in the back of the book for 1.8, it's going to give you a value of 0.461. That value of 0.461 has to do with this area under the curve here. So then you have to, do the product rule, say 0.5 minus 0.461, 4.641. And that's going to give you this down here, which is 0.0359. So this green shaded area, which is the area that we are actually caring about, is 0.0359. So from this, we can say, yes, it is unlikely. A less than a 4% chance that the sample mean is equal to or greater than the 31.38 ounces that we found in that 16 bottle random sampling. Questions on this example? Excellent.